Might Proxima B in the end be another Earth-like planet? These are hypotheses. Everybody continues to make the excursion for another option. Nice planet. An extraterrestrial life on different planets is something people are captivated with. There have been different hypotheses, and the way that there have been signals coming from Proxima causes individuals to recognize there is one more side to it. Dismissing these various signs, we actually can't decide if these are messages from the planet or simply replays of our own researcher standards routinely achieve reverberations. In checking whether these signs are genuinely from Proxima B, examiners need to decide whether extraterrestrial life exists. As of late, the James Webb Telescope recognized counterfeit lights on Proxima B. Assuming you're energetic about finding out about different planets and our advancement in tracking down substitute life, buy into our channel. We make content about space and examine headways in science. Assuming that you like this substance, remark underneath and share this video with your companions. Presently we should get back to our video. Proxima Centauri around 4.2 light, a very long time from our planetary framework, is a weak little star named a type. This star is known as Proxima Centauri. It was named Alpha Centauri in 1835 by Johann Bessel. Got from the stars ascending around early night when a couple of heavenly bodies similar to the moon and the sun were in an organized line. Proxima Centauri is otherwise wise called Alpha Centauri N or Alpha Centauri. It is a solitary star framework with 4 essential stars in a line. Proxima Centauri is at the focal point of this framework, isolated from the 4 stars. There are 2 weak minute mates, Alpha Centauri B and Alpha Centauri C, which make up the greater part of the mass, however, are excessively powerless to be seen by the independent eye. The framework is tracked down 23 light, a long time from the line of the renowned Furo asterism in the group of stars and Taurus. In spite of the way that Proxima B is a rough planet, there is still expectation that it could hold on to extraterrestrial life. The quest for one more life out there has carried experts to Proxima B. They trust the likenesses to Earth's size and the distance it is from its little star created a reasonable possibility for planets that can oblige life. While these are speculations, there is trust that they could hold some reality. There is a lot to find out about Proxima B and its circle, so remain tuned and continue to watch. You can likewise look at a portion of our other substance connected with extraterrestrials. Do you genuinely trust there's other life out there? Leave a remark down underneath. What intrigues the vast majority about Proxima B is its similitude to Earth. Concentrates on show that Proxima B is an exoplanet that circles type star. Its mass is viewed as 1.27 times that of Earth. Furthermore, Proxima B requires 11.5 days to finish one circle of its star. It was found in 2016 and numerous researchers are concentrating on it. Despite the fact that Proxima B looks like Earth, certain elements make it less neighborly. As far as one might be concerned, the planet is excessively near its star and in this way keeps on getting outrageous bright radiation from the star. It is assessed to be a few times more extreme than the radiation we get from the sun. This radiation is sufficiently able to strip away even the lightest hydrogen particles, and over the long run it does likewise to oxygen and nitrogen. While many could contend that Proxima B ought to be livable on the grounds that it is at a comparable separation from its star as Earth is from the sun, there is something else entirely to it. Distance doesn't decide if there is water in the world. There is additionally no proof of an environment that would uphold life. Earth's environment makes it reasonable, while Mars doesn't. The right air makes it workable for organic guideline, and a water accommodating surface. It likewise safeguards living creatures from hazardous space climate. On the off chance that you're with us as yet and haven't bought in yet, pause for a minute to raise a ruckus around town. Button it makes it more straightforward for us to continue to make content like this that you'll cherish. Presently, how about we see the reason why individuals think the James Webb Telescope will assist us with sorting out whether there is life on Proxima B. The James Webb Telescope was sent off in 2018 in the wake of being deferred starting around 2011. Many changes must be made to guarantee it gave precise pictures during its creation. Webb made sense of that in the event that a planet like Proxima B could retain light from its star. It could likewise transmit it as infrared light. The James Webb Telescope was explicitly intended to notice infrared light. You can take photos of this light on the outer layer of a planet and quest for designs that could affirm assuming the planet has water or an environment. One explanation space telescopes are liked over ground-based ones is that by being over the climate they don't have to glance through the moving air to see profound into space. Subsequently they get a superior perspective on what occurs outside the planetary group than most ground telescopes can accomplish. One more benefit is that weather patterns on Earth don't influence them, and space experts should rest assured they're getting a reasonable perusing. The fundamental disservice to having a space telescope is that fixing it is expensive. Assuming something turns out badly, there have been circumstances where a minor imperfection tie in a space telescope expected a full mission into space to fix it. Such costs make noticing planets like Proxima B troublesome with the James Webb Telescope, since it has been sent off over 1.5 million km away, farther than any human has at any point voyaged. Salvage missions are unthinkable. The James Webb Telescope accompanies a bigger mirror, permitting us to consider to be far back to the beginning of the universe, almost 13.7 a long time back. The further away an article is, the further back in time we get to see it. The justification behind this is that light requires some investment to travel the capacity of the James Webb Space Telescope to see the universe in a more extended frequency. In infrared light means we get to see more far-off cosmic systems in our universe with more clearness than was beforehand conceivable. Thusly, noticing planets like Proxima B has become more straightforward. Tabor and Twist have a scale for fake light which shows how the sun enlightens and mirrors the day side of a planet. At 0% on the scale, one would expect the planet's night side to be totally dim with no light. At 100%, it implies the planet's night side is similarly just about as brilliant as the day side. There has been hypothesis about a human civilization on Proxima B utilizing this kind of light, and most specialists accept it looks like the good old days on the planet. Concentrates on show that assuming that the night side of Proxima B arrives at a light degree of 5% of the typical day side, then at that point the James Webb Telescope could recognize the fake light. By 85%, assuming that the brightening arrived at 9%, the telescope would distinguish up to 95%, albeit 5% light appears to be a modest number. We're discussing light from a star like Proxima Centauri, contrasted with our sun Proxima Centauri. Light is a lot dimmer. However, we actually have a ton of light from our star. This basically implies that even at 0.1% brilliance we are as yet mirrored in the divine light. All in all, assuming Proxima B has any human progress, that is, utilizing counterfeit lighting like Earth, the James Webb Telescope probably won't distinguish it. The stars should be around 500 to multiple times more brilliant. This situation is far-fetched since Proxima B circles so near its host star that it very well may be tidally locked, meaning one side of the planet continually faces the star while the other remaining parts in never-ending night. Living on a tidally locked planet would require zeroing in on enlightening the night side and utilizing extremely splendid orbital mirrors to reflect daylight from the day side to the night side. These are hypotheses proposed by Tabor and Twist, and there is yet to be confirmation to show they are valid. The planet's brightening ought to be noticeable from space and is known as airglow. Many individuals can't help thinking about why the world is encircled by brilliant shades of red, yellow, green, and purple light when seen from 300 mil over its surface. Air glow happens when particles and atoms in the upper climate discharge light to deliver abundance energy on the planet. Air glow can happen when particles and atoms are ionized by daylight and catch free electrons. The gleam of air glow is like an aurora. Then again, actually auroras are driven by high-energy particles from the sun-based breeze. The air glow is driven day to day by sun-oriented radiation. Since the James Webb Telescope send-off, specialists have been addressing whether noticing far-off planets and distant worlds is adequate, notwithstanding being the farthest satellite telescope at any point sent off. It actually gives exceptionally restricted data expected to track down planets with life in different universes. Accordingly, there have been conversations about making bigger and better telescopes. These endeavors are frequently costly and include a great deal of experimentation. The James Webb Space Telescope send-off was 5 years late because of these issues. Consequently, it is moving for most analysts to foster better innovations that can be sent off further into space. In spite of this, the James Webb Space Telescope's outcomes are promising. Before long we could know whether there is life on Proxima B and different planets, while work is as yet being finished on extra telescopes. The normal culmination and send-off of the Habitable exoplanet observatory will upset space investigation. The assessed finishing time for Habitable is 2035, with a send-off soon after. Habitable will be delicate to all planet in the universe, despite the fact that its principal objective is to look for Earth-like planets. Its state-of-the-art innovation will empower it to quantify the spectra of most planets and decide if they are livable. Habitable is likewise expected to have a large number of cosmological capacities, permitting it to concentrate on the earliest potential times in mankind's set of experiences, accumulate information, and comprehend the existent cycles and passings of gigantic stars, as well as the components that help life, as we probably are aware at tidal